Welcome to Tech Talk, your tech survey program. I'm your host, Jabulani Tunani Kumalu, and today we are at the HICC, where the Industrialization Week is being held. And we are going to talk with different inventors, and one of them is Mr. Victor, an engineer from ZINGSA. But before that, let's get into history and trivia. Everyone knows about satellites, from those that we have mounted on the roofs of our houses to receive television signals, to the ones that we have in space sending these signals down to us so that we have something to watch. Well, that is just the small use of satellites. In fact, satellite is defined as any object that revolves in a curvy path around a planet. As such, there are two types of satellites: the natural satellites like the moon and the sun, and the artificial satellite, which are launched into orbit by people in a two-step process. First, the satellite has to be taken to the desired altitude by a rocket or a space shuttle into space. These rockets or space shuttles is also called a launch vehicle. Next, the satellite is then pushed off into space at the right velocity to begin and maintain its orbit. The launch vehicle travels straight up only for the first few seconds of its flight. When it finally reaches the proper altitude and speed, it releases the satellite into the orbit.
Sputnik 1.
First artificial Earth satellite to be launched into space. A historical first achieved by the Russians on the 4th of October 1957, weighed 83.6 kilograms. It was a 58 centimeter diameter sphere made aluminium and transmitted a simple radio signal back to Earth for 21 days and remained in the orbit for almost 6 months. Much to the dismay of the United States of America, which thought then it was far ahead of the USSR in terms of space technology, the Russians went on to launch a second satellite,
Sputnik 2.
on November 3, 1957. Carrying a dog named Lycan into space, they became the first nation to successfully send a living organism into orbit. The United States of America then launched its first satellite on 31 January 1958, called the Explorer 1, which carried experimental equipment that led to the discovery of the Van Allen radiation belt. Since then, there has been several satellites launched into space. It's important to note that celestial bodies and phenomena in space. This satellite has a vision that is 10 times better than the most powerful telescope on Earth. While most satellites are owned and operated by Western and Eastern countries, African countries also have at least 59 satellites in orbit. The first being launched by South Africa in 1998, called Sunset 1. The latest satellite launched by an African country is NetSat 1, launched by Egypt on February 3, 2024. Zimbabwe is one of those countries in Africa that has a satellite in orbit, a cube satellite called ZIMSAT 1, launched on 7 November 2022. Together with Uganda under the joint global multinational birds satellite projects, a multinational program to help countries develop their satellites. These satellites are to help monitor and analyze life on the ground so as to improve life in these countries, from crop analysis, monitoring weather, and human activities such as land use and occupation. By the end of 2024, Zimbabwe is expected to launch 2 satellites. That's all we had for you in this first segment. Join us after this break as we talk to Zimbabwe's very own space agency, the Zimbabwe National Geospatial and Space Agency, ZINGSA, as they share more on satellites and the drone technology they have developed right here in Zimbabwe. Welcome back to the second segment of Tech Talk, and right now we are joined by aerospace engineer Victor, who's going to be explaining and telling us all about the whole system that we see behind us here of Zimbabwe International Geospatial Space Agency. So let's talk to Victor. Welcome, Mr. Victor.
Welcome. Hello, Zimbabwe.
Please do walk us through the whole geospace and what do you do?
Okay. As the Zimbabwe National Geospatial and Space Agency, we are under the Ministry of Higher and Tertiary Education. What we specialize on both space and ground-based technologies. And we have 5 departments, which is the space engineering, geospatial and space observation. We have space operations and launch, and we also have the space engineering department, the space science department.
All right, beautiful. So, Mr. Victor, I want you to walk us through the whole space engineering and geospatial agency system, how it works and what it's all about. And I see there are a couple of tools right behind me, and one of them is the Birds 5 project, one of the first satellites to be launched into space for Zimbabwe, and you were part of the team.
Thank you.
The engineers there. I have much appreciation for that. So this one is the second one, as you said.
Yes, yes.
And you're about to launch it.
Yes, yes.
That's beautiful. So we want to know what do you do and what are the tools behind us and what do they work?
Okay, thank you very much for this opportunity. I am the head of the engineering department, so I'll take you through before the set what are the processes that go through the satellite. So we start from computer-based designing, where we do the designing of circuit boards, we do the structural designing. It can be a drone, it can be a satellite, it can be a total station for survey, it can be any gadget that we want to design. So we can tailor-make any design of any product depending on the customer's needs. So for electrical components, we have a PCB assembly SMT line for making PCBs. These are PCBs. They are made and then holes are drilled. And we also have some CNC machines for cutting metals, which I will take you through. So once a PCB is made, it's designed from the computer, it's printed on the assembly line, it will not have all these components. Then the second stage after this is that we go on to the population of the PCB, whereby components are mounted, we solder them on the PCB using this third hand and the glass to view the magnifier to see the components. Then after these components are viewed, they are gone for further assessment using this microscope, whereby we check whether there is any short circuiting on these. You can see the small holes that are being seen here. They are connecting various cables underneath.
So this is like a digital microscope?
Yeah, this is like a digital microscope. You can adjust actually to see any zooming capability you want. You can do it. Then after these, we go on to testing each and individual board as a system. This is a camera before integration. This is a camera after integration with a Raspberry Pi, and you can see these are standard memory cards where data from the camera is being stored. This is after integration to this board. Then after we integrate them, we now put them. This is a 3D printed satellite model. This circuit board is made to be inside the satellite model. This is another view, or can I take you through this satellite? This is a model of ZINGSA-1, and these are the cameras that I see. This is the antenna, these are solar panels. So the structure from the designing, again, we make the structure, and the electronic circuit boards are made, and we integrate them into a satellite. This is a ZINGSA-1, and this is soon coming ZINGSA-2 models. And we also print a drone. This is just a small part of the wing. You can see this is a profile of a 3D printed model. This is a wing that is used to mount on drones, and we use various drones for various applications. We also make metallic structures whereby you can see this part. It's exactly an overlay of this. This was a part which was reverse engineered from the Agras T30 drone that is being showcased on the screen. We do reverse engineering, and also we do manufacturing of various things such as drones, satellites, other other electronic that depends on the customer's needs. Also, on the engineering department, we have this project. We are doing collaboration with other government parastatals such as ZETDC, whereby we are using these known as the GIC project, whereby we are measuring the activity of the sun. We normally say the sun has risen, but when it rises, the sun produces solar wind, and which some of it enters the earth, as you can see from this banner here. The solar winds. This is the earth, and then there are some particles from the sun that comes inside our earth through the aurora zones. So these induced currents, these particles cause induced currents on our transformers. Most people, they see ZEDC transformers blowing and burning. They don't know what is the cause, but it's actually due to the activity of the sun. And next, we're in 2024. In 2025, that's when the sun is going to be at its peak in its activity, and we are likely to see some transformers burning for electricity and some electrical disruptions. This is caused by space weather. As you can see, we are measuring what is known as the KP index, where we are measuring the activity of the sun, these graphs. So whenever we have a peak, whenever the value goes, whenever we have a peak, it's known as a storm. We'll be having a storm. And when you have a storm, usually at the end of the transmitting line or the transformers are bound to burn. So we have mounted these on various substations in Zimbabwe through our collaboration with ZEDC, and we are monitoring. This is the inside the unit. We have made the electrical components with the same procedure that I've demonstrated. This is mounted on the power lines to check whether there are any induced currents on our power lines which cause disruptions in our power.
Okay, beautiful. You've explained well. In terms of 3D printed materials,
Yes.
I've got my cue holder there. It was printed in 3D. And it has the logo on it. It's beautiful. I'm going to keep this.
Yeah,
Anyways,
thank you. You can have a red one.
I can have a red one as well.
Yeah.
Okay, I've got two now. So anyways, we want to know, like, you were explaining about this system.
Okay.
Saying that it controls the amount of, I don't know, fertility or something like that has to do with soil.
Oh, okay.
So please explain.
All right, this is known as a ground sensor terminal. The ground sensor terminal, it acquires data from remote locations. For example, when we're in Harare, we don't know that in Chimanimani or in Masvingo, which is where I come from, there is rain or not. But using this device, which is known as the ground sensor terminal, it acquires the rainfall data, wind data, among other, like pressure and magnetism, like in relation to that same project. And the data we are receiving, data currently is taking the data of, you can see magnetic and then the wind value, the wind vane. So it has a wind vane that is mounted on it. So this unit transmits to the satellite, and from the satellite it comes down to our ground control station. It comes down to our ground control station, which we then now see on the ground station, the data that is coming from the remote station. So we have mounted these on 10 different provinces, all 10 provinces of Zimbabwe, and we are receiving data via the satellite from this communication to our ground control station using the ground sensor terminals. And we can integrate it to anything. For example, we want to know the water level of Kariba Dam. We want to know how the water quality in any dam is like. We want to know the soil fertility. We just need to mount sensors on there, and then it will transmit data via any data. It transmits data from the ground, remote locations, to the satellite. Then the satellite transmits back to the ground station.
So it works in coordination with the satellite.
With the satellite, yes.
That is very beautiful. So we want to know some of these models here. Are these the only pieces that you have, or there is more to it than these?
There is more to this. Actually, we are limited with the area of the stand, but we have printed drones. We have 3D printed drones. We are reverse engineering drones. We have other engineering projects that we have that cannot fit in this. We have a mini in this space. We have a rocket that we have. But just
rocket, yeah.
yes,
Wait a
we,
minute, you have 3D printed drones
yes,
that actually work.
that actually work. Yes.
How do you print the little components inside and everything? How does it work?
Okay, this one is just a mini for exhibition purposes, but we have an industrial 3D printer that is a bed of about 2.5 meters. So we print a very big wings, and we print them in parts. We print left wing, right wing, the body, among other things.
You
So
put them all together, okay?
this, as I've said, it's a profile for a wing. It's just a tip, a tip for a 3D printed tip for the wing.
For the whole part.
For the airframe of the drone, yes. So we have various drones. I will take you through in our next session on a segment on this, but this is basically what we do at ZINGSA. Even on our brochure, we did the winter wheat harvest estimation. You can show it. We did the winter wheat for Zimbabwe. Through our geospatial and earth observation department. It has various projects like we do also mineral exploration. We also do mapping. We also do wetlands mapping, among other. These are residential stands that are mapped. We mapped this in Caledonia. This was mapped by ZINGSA for titles. We make titles. You can saw the winter wheat. These are titles in Caledonia.
So these are all made by drones.
Yes, these are made by drones. Yeah, you can see here. Go back. Yeah. Oh, these are wheat, and these are, we have algorithms that we map wheat and barley for winter wheat, and we do have estimation, which this data is used for strategic decision making.
Okay, that's all we had for you on this second segment. That was Victor there explaining the whole operations of the systems at ZINGSA. Join us in the next segment as we go to the drones and get the whole rebuild of how it works. Welcome to the third and final segment of Tech Talk. As you can see in my hands, I'm holding one of the controllers of the Agra, I don't know the whole name, but it's about agriculture. It's a drone, guys, that is used to irrigate or fumigate actually one of the chemicals or any chemicals that you want to put in your crops or any type of system that you use it for. So there's two of them. This one works first before that one, the big one, is used. But with me here, I have Gloria Arohanya, the land surveyor, to describe the whole system and how it works and how we operate on this machine. Before I break it, let me put it down. So Gloria, thank you so much for taking your time to be here. I want you to go through the whole process and show how it's all done and how it all starts.
So as we all know that agriculture is one of the key economic sectors in Zimbabwe, as ZINGSA, we have seen that we need to introduce drone technology and satellite technology in agriculture. So we all know that we use those boom sprayers and tractors to spray, but then we have introduced these drones, the Agras, and this is the Mavic Pro Enterprise, to facilitate the spraying, because it's tiresome using those boom sprayers, and also those seasons when the fields will be wet and won't be accessible physically, and we need drones. So this Mavic, we fly it before, and then we get the map of the field, and then we then load the map in this controller here, where we can do our targeted spraying with the Agras. We can actually see that this is the area that is more affected, and then we need to put more chemicals on this area, and then we can all do that with this drones, rather than you trying to see physically doing the job. And also for sustainability, with our satellite technology, we can actually map the way we are applying our fertilizers. Is this sustainable for the next 10 years or 20 years to come? So what we have done is that we do the image classifications from the satellites, and then we use those images to see how much yield are we expecting this year, and then we inform the decision makers so they can see where there is need for intervention used on the results we would have given them, and maybe they'll see that this area was allocated for farming, and maybe the farmers are not farming, and they go there and they have a talk with them and see the challenges they are facing or whatever. Let's say we have done the estimation, and we have seen maybe we have shortage, and then the policymakers, they then decide to import, and then maybe if we have excess, and then we might need to export. So as you can see here, this on the drone technology, we have a controller here. So the camera is here so that our drone can actually see the obstacles and everything. So what we'll be seeing here on our controller is what the drone will be seeing. So that's how we manage to control our drones, maneuvering these, going up, down, and then it can actually land. So let's come here to our big drone that actually does the spraying. So as you can see, we have this tank here. That's where we put our pesticides, and then we have also the batteries to supply the power to our drone. It will be flying, and then we have these propellers to facilitate the flying of our drone. So this drone is actually faster than those traditional methods that we have been using. So we are encouraging our farmers to come to us so that we can collaborate for the betterment of our nation, and also to achieve our goal of having much food security. So I think this is more that I had to say.